All right, good morning, grade 12s. So one last example for section 5.4. I told you at the beginning of the chapter that we could use trigonometry to model real-world situations. We talked about periodicity and how some things change over a period of time and they keep repeating and repeating and repeating. So one of those situations is the average temperature, average monthly temperature throughout the year. So here's some data for Whitehorse in Yukon. We've got the month up top here, and we've got the temperature down below. So the first month, January, I would presume, average monthly temperature -18, all the way to a high of about an average monthly temperature of 14 degrees in the month of the 7th month, which is July. So I want to show you how we can model that data with the trig function and how we can use technology to do so. So what we're going to do is we're going to input this data, this first list here, list 1 and list 2, into the calculator, and we're going to let the calculator calculate, I guess, or compute what the sinusoidal equation is. We're going to do what's called a regression equation. We're going to work backwards from the data to create an equation. So the first thing you need to do is go to Stat. Okay, right up here, the Stat key. Touch on that, and we're going to clear anything that happens to be in our calculator. We're going to pick list 4, just so I can show you here actually what that looks like. If I hit enter, I'll see list 1 has some information, list 2 has some information. There's a couple of ways to clear it, but one of the fastest is just to clear everything by going down to number 4. It'll say clear list, and then I have to tell it what list, and I want to clear list 1, comma, and then list 2. So I go second function, list 1, I hit the comma key, and then second function list 2, hit enter, and I'm good to go. It tells me done. So I can go back to Stat and enter. I'm going to edit my lists, and then I can start populating those lists with information. And I know that these are my months, and I'm going to go from 1 to 12. So 1, enter, 2, enter, 3, enter, all the way down to 11. To 12, enter. So I've got my list 1, and then I'm going to go over and start populating list 2 with the same numbers, or not the same numbers, but the second list here. -18.4, -18. Be careful about making sure you get the right numbers in there, otherwise it throws everything off. Enter, and -13.4, enter, all the way down to -15.7. So at the end, anytime you fill lists up like that, you want to make sure that your last two pieces of data match up. Right? If there's a discrepancy, then things don't work out. So we've populated our lists, we've got our data in, now we're going to calculate the regression equation. So here's how we do that. We go to Stat, because we're working with some statistics, and we want to calculate something, so we go over to the calculate menu, and you see these reg here, lin reg, quad reg, cubic reg, quartic reg. These are all regression equations, and we're going to look for the sinusoidal regression equation. Happens to be at the bottom of the list, so to save a little bit of time, if I go up, it brings me to the bottom of the list, and I can find this sinusoidal regression here. So hit that, enter, and iterations 3. Never actually seen that before. That's awkward. Let's find out what that means. So it's going to use the my X list is going to be list 1. That's true. My Y list is going to be list 2. That's good. And let's go down to calculate. That's a little different than what you'll see on your calculators. So sin reg, and there we go. So you've got a sinusoidal regression equation. It's going to look a little different when you do it on yours. Okay, I'm just a little surprised here. And now I want to plug that in to y equals. So I want to go into y equals, and I want that big long string of equations with all the decimals to show up in there. So I can go to variables. We've used this key before. And I want to bring in from statistics, because I was working with my data, I'm going to bring in an equation. So I go over to EQ, and I'm going to bring in that regression equation that's there. So I don't see all the information, Okay, but this is the last decimal place of a long string of calculations, or long string of information. Okay, etc. So if I choose my window settings carefully, I'm going from the first month to the 12th month, and I want to see a little bit beyond that. So I'll go maybe from -1 to, I don't know, let's go 15. And we'll show every month. Our lowest temperature was -18.4, so if I go -20, that should be enough. My highest temperature was 14, so if I go a little higher to 15, that should be fine. And maybe this time we'll go up by temperatures of 5 degrees. So now when I graph it, let me just make sure that my mode is in radians. Yes, it is. I've got this curve. Now, it'd be neat to see if that curve matches up with my data. So here's how I can do that. Just above y equals, I can see stat plot. Right? So if I go second stat plot and I turn it on, oops, we'll turn number 1 on. I want it on, that's going to be good. I want the dots to show up, not connect them with the line. And I want to use x as list 1, y as list 2, that's all good. So I'm just going to hit enter. And then graph. There's all my data. And there's the curve that I created that goes through that data. It's not perfect everywhere, but it's a pretty good example. Now if I go back to the equation, you'll notice that there's a lot of decimals there. And if I was going to try to plug that into y equals, I'd probably make a mistake, knowing me anyways. So that's why I went to y equals, and I went to, if I do it over here in, well, let's actually clear that one. I went to variables, I went down to statistics, and then I wanted an equation that I had already created. I wanted the regression equation. Boom, enter, and I've got all my decimals. If I want a cleaner look, if I want to write down my equation, one of the things I can do is go to mode and pick the number of decimal places that my computer, my graphing calculator, will calculate. So if I showed 2 decimal places or 3, etc., I could do all that stuff again. I go stat, calc, I want the regression equation, go down to calculate, wait for it, you can see it's working over here, and then I've got something nice that I can work with, and I could actually write that equation out. I'd get that y is equal to, let's bring that up so I can actually see it, 16.79 sine 0.47 x minus 1.70. Oops, sorry, my bracket's in the wrong spot here. Sine 0.47 x minus 1.70 and then minus 2.77. Notice that it gives me my b value inside there as a as part of this x minus h term. So when I factor that out, my phase shift will be different. Okay, there's my equation. Now, can we do that algebraically without the graphing calculator? Well, yes, we can. So if we let x equal the month and y equal the temperature, then we can create our own equation. I know that here the graphing calculator created a sine equation, but we're going to work with creating a cosine function. And I'll tell you why. It looks like the data starts low, goes high, and then comes back down to low. So that's, an example of a negative cosine function, because normally the cosine function would start high. The sine function will just have been phase shifted to this point, and that's what's going to be represented here. If we pick a negative cosine function, we don't have to worry about a phase shift. So let's see if we can make use of that. Now we can calculate the a value, the absolute value of the a value here, by going max minus min divided by 2. Our maximum temperature was 14. Let me change back to a different color here. Our maximum temperature was 14.0. our minimum temperature was negative 18.4, and divide that by 2. 14 plus 18.4 gives us 32.4, and divided by 2 gives us 16.1. So our amplitude is going to be 16.1. Not far off of what the graphing calculator calculated. Our period remember is 2 pi divided by b. So the period is 12 months. That means 12 equals 2 pi over b, and b equals 2 pi over 12. So our b value is going to be pi over 6. Pi over 6, by the way, if we go pi divided by 6, we get 0.52. Again, not far off of 0.47. If we're doing a negative cosine function, I don't have to worry about a phase shift, and so I can leave c out. And d, that's the beauty of choosing the proper function, whether it's positive sine, positive cosine, negative cosine, to model the data. And then finally, d is equal to our max plus our minimum divided by 2. So 14 plus negative 18.4 divided by 2. That's not a negative. 14 plus negative, that's like saying 14 minus 18.4, which is negative 4.4 over 2, or negative 2.2, which was, is that close? Yeah, not far off. So our function then becomes y is equal to negative cosine, or negative 16.1 cos of the b value pi over 6 x with no phase shift minus 2.2. Now I'm going to put that into the graphing calculator and see how close our equations match. So I've plugged the equation here into y2, and to show that the first one is going to be the regular line, I'm going to pick my second function and make the line darker by going over to the far left, hitting that, and I'm going to get a darker, thicker line. It'll be bold. So now when I graph that, I can see the first line going in over my data points. That's the regression equation that the calculator computed. And then here's my second one. I see something. Okay, so a little bit off. And one of the reasons for that is because we started at 0. But my graph actually starts at 1. So how can I make that change? All right, well, we saw that it was shifted a little bit, so I did a little bit of exploring and thought about it. Remember that our first data point talks about our lowest point here being at 1, right? At month 1, and we didn't take that into account when we did our equation. So if I think of my c as being equal to 1, then my equation is going to change a little bit. And all I have to do is go same b value and then x minus 1 to show that it's going to the right and close off my two brackets. So I've still got my amplitude, I've got my b value that determines my period. I've shifted to the right one, and I've shifted up or down 2.2. So now when I go to my graphing calculator, I've already plugged that in here into y2, and I've shown that it's darker, so I should be able to graph that. There's the plot. There's the first equation. Now the computer calculated that one, and here's the one we did by hand. Doesn't look too bad. Not as precise, okay, but it looks like it works for the given data. So we're going to be able to work with both of those methods and practice that today. Alrighty, bye-bye.